Welcome to Epistemology.
You know what I like a lot more than materialistic things? Knowledge. What is this?
It's a podcast. It's time for another episode of Epistemology. My guest today is Reuben Finigan. Reuben was a Fulbright Scholar and Frank Knox Fellow at Harvard's Kennedy School of Public Policy and is now a Sir John Monash Scholar and Labour-Hume Trust Fellow at the London School of Economics, where he is finalising his PhD in political economy. Reuben's work is quite eclectic, but our conversation today focuses on his thesis, which applies various models from biology, especially concerning evolution, cooperation, and parasitism, to explain contemporary issues in political economy, notably corruption, innovation in anti-competitive practices, and how we should think about designing market regulation. If you've never thought that pollinators could teach us about how to run the internet, prepare to have your mind blown.
The watchdog of public safety. Is there any lower form of life?
Don't worry, sir. I rounded up our less gifted employees and led them into the basement.
Homer, why are we down here?
Oh, jeez. I told you, Bernie, to guard the bee.
But why?
Oh, you guys are pathetic. No wonder Smithers made me head bee guy.
It's getting away.
Oh, we did bad.
Epistemology.
Welcome, Reuben Finigan, to Epistemology.
Great to be here. Thanks for having me on.
Awesome. So tell us a bit about what you study in your research, what you're passionate about, what gets you intellectually fired up.
Everything gets me intellectually fired up, Mark. I started out my education with arts science, like 5 different majors in physics and chemistry and psychology and all this stuff. Went through working on climate change and climate economics and behavioural economics, and now I've ended up sort of in political economy, and all the different things I've studied are being mashed together in this thesis. So I guess you could say I love knowledge in general. I love different frameworks, and a lot of my work is really reaching across disciplinary boundaries and seeing how these disparate things can plug together and form something new and interesting.
Nice. Hot. Okay. Well, you sound like a perfect guest for this podcast. So you mentioned interdisciplinarity there, which is something very close to my heart. And I think one of the areas that you work on a lot is sociobiology, which is kind of interdisciplinary space. So could you tell us a bit about what sociobiology is and maybe why people should be interested in it?
Sociobiology is a subfield in biology that aims to explain social behaviour in terms of its biological bases and how it evolved. So it's concerned with everything from mating patterns in turkeys to the territorial behaviour of koalas to the behaviour of human beings in families and in modern states, how we relate to groups. And the idea is that a lot of these behaviours that human beings manifest, if we're talking about the sociobiology of the modern human being, is that our behaviour echoes our evolutionary context, which was one of people living in sort of kinship groups, but mostly living in groups with unrelated individuals with whom they had to work together to compete against other groups. So that's where sociobiology enters into political economy as a sort of foundation for thinking about the nature of the human agent that we're dealing with and what drives them. And so obviously a lot of the behavior of human beings today reflects evolution, as in you have, we have a pretty strong drive to eat, a pretty strong drive to keep ourselves away from the edges of cliffs and lions and all these sorts of things. We've got a strong drive to find ourselves a partner and reproduce. We tend to hang out with our families more than the average stranger and look after them and care about them. which is exactly what evolutionary biology would predict based on the fact that there's shared genetics between individuals and their kin. So in my thesis, the role sociobiology plays, well, firstly, it's drawing a lot of parallels between neoclassical economics and evolutionary sociobiology. So interestingly, they share a lot of properties because they're interested in some sort of agent, which could be in biology, it could be a gene, could be a species, some sort of carrier of evolutionary interests. And in that's an interest to reproduce, whereas in economics, it's an interest to maximize utility. There's a whole landscape of possible strategies that the agent can use. There are these gains to trade, gains to cooperation, and having a division of labor. But what my thesis focuses on a lot is that there's also gains to defection. And to carry on the list a little further, there's also they've got innovation. In biology, it's mutation. In human societies, it's the process of invention, of new social strategies, new technologies. And so you've got all these properties in common. And so scholars have applied game theory both to biology and especially sociobiology, and to human economic systems in a very, very similar way. Some only very subtle differences that don't really they don't make that much difference. That is, biology, evolutionary game theory is more about populations rather than individuals playing games. But so
what is game theory, just briefly?
Well, so game theory is Mark, how would you describe game theory?
How would I describe game theory? It's a branch of mathematics, or a subfield of mathematics, pioneered by John Nash, poorly represented, I think, in A Beautiful Mind, but nonetheless, there's a popular representation of him. And the basic principle is that you try to model games, but I guess of particular interest, you try to model strategic behaviour in games. So famously, the prisoner's dilemma is perhaps the most well-known game, where you have two prisoners in separate rooms that can't communicate. And if they follow their story that they've agreed on before being interviewed by the police, then they'll have a better outcome. But they can't trust each other, because if one of them defects then and tells the truth, they'll get a lenient sentence, whereas the other guy will get punished. And if we represent this problem mathematically, we can see that it's rational, in scare quotes, for both prisoners to defect, which ends up with them both getting a really bad outcome. And these kind of modeling principles can be applied to a whole range of behavior. Some of the things that you talked about earlier, like the mating behavior of koalas and territorial behavior and things like that. And then famously to political economy issues, like whether a group of humans should all cooperate to manage a collective resource like a fishing basin, or whether you can't get that cooperation because there's just too much of an incentive for people to defect. Do you have any? What have I missed?
You did a beautiful job, Mark. And so the difference with evolutionary game theory is you're dealing with populations. And so if you take the prisoner's dilemma and say you got a population where the people are randomly playing the prisoner's dilemma with their neighbors. So it's a sort of structured community. And then what you have is, the strategies can sort of appear a bit random within the environment because of the process of mutation. Just sometimes they turn up. Or, if we were talking about an evolutionary economics point of view, well, people just come up with ideas and they rediscover ideas periodically. So if you've got the difference is that in a sort of one-off standard prisoner's dilemma, where defection always wins, and that's the solution. The Nash equilibrium is defection. Or if it's an iterated game, then the Nash equilibrium is cooperation. And so voila, that's solved. When you have this population playing the game, then instead what you have is, you've got, like, say you begin out with a mix, and a mix of cooperators, well, say conditional cooperators, who will cooperate only if the other partner cooperated previously. You've got defectors, and then you've got altruists who always cooperate. And so obviously the defectors are going to eat the altruists, and they're going to do well. But then the conditional cooperators control the defectors. And so then what happens is, say, conditional cooperation is starting to spread. When there's enough conditional cooperators, that creates conditions in which an altruist can then invade. And so altruists start to be able to go in because the conditional cooperators will cooperate with them. So if you've got a completely, 100% cooperative system and altruists invade, 100% cooperation just continues. And the altruists, because they always cooperate, say their strategy is a little bit cheaper to implement. So they do a little bit better. So then they end up spreading and rising up and taking over the community. And then that creates a niche for defectors. And so then the defectors can come in and start eating the altruists again, which creates an opportunity for conditional cooperators. And so you get this rock, paper, scissors sort of cycling patterns in population game theory, in evolutionary game theory, which is quite interesting.
Could you maybe just give some brief examples from nature, maybe, of animals that we see as having a lot of cooperators, or having mostly defectors, or having more of this kind of mixed situation like what humans have?
Well, it's sort of similar. I guess you could look to primates to find something sort of similar to what we have. But I mean, you could even look at the relationship between, say, pollinators and flowers, where so flowers, it's actually talk about this in my thesis a bit. You can set this up as or frame what's going on in these interactions between pollinators and the flowers as a sort of market. You've got flowers that are putting out the advertisement and saying, look, here's my product. And they try and put out a very showy sort of signal for this product. And then you've got the bees that come in and they choose. They use some sort of cognitive mechanism to choose. And they, in return, they provide the flowers with the service of transporting their pollen to another flower, so that the plants can reproduce. And this is an interesting sort of system, because the way that lay people think about pollinators, bees and flowers, is that this is, it's a sort of archetype of cooperation and of a happy sort of division of labor. But actually, it's a very much more complex world, a lot more like real human markets, where you've got particular sellers trying to deceive the consumers, and consumers trying to steal from the sellers. All these sorts of things happen. And so you've got flowers that will use various sorts of tricks to take advantage of the particular cognitive structure of the bee. Some of them provide an addictive compound. Some of them put on a sort of display, but actually, looks very compelling. But about 4 in 5 of the flowers are duds. But they still get them with pollen. Other ones set up traps that dab the pollen on the back of the pollinator, and others mimic the pollinators' sexual partners to get them to come in and don't give them anything at all. And so you've got all these behaviours where there's, I guess what's interesting about this in light of my thesis is the sense in which the efficient outcome, the outcome that maximizes productivity, much like the human market, is one of full cooperation.
Mm-hmm.
But for individual species and their members, there are lots of advantages to defection. If you had too much defection, then the whole pollinator flower sort of system would collapse. And so, yeah, it's a sort of getting onto the race a bit between the Red Queen's race, which I know you want to talk about today.
Yeah.
Would you like me to?
Well, I guess you can, but maybe before we get to that, might be worth just sort of foregrounding it a bit by saying that the situation you've just sketched, where we've got the sort of optimal outcome for everybody would be full cooperation, but we always have these defectors. And so a long-running subject of inquiry in political economy has been trying to figure out why some communities or some species or some institutional arrangements result in greater levels of cooperation than others. And that's quite interesting. So like communism in practice, for example, fails to bring about cooperation. It tends to engender a lot more rent-seeking behaviour or corruption. And then also trying to figure out how we move systems towards greater cooperation or these outcomes. So I know a big theme of your thesis is sort of regulation, and often regulation's objective in a way is to try to circumvent these defection strategies to encourage a more cooperative equilibrium. I think maybe another thing we need to foreground that I'll hand over to you is just the difference between individual level selection and group level selection, because that seems quite fundamental to some of the topics we'll talk about as we go on. And I know that that's kind of a spicy topic in biology, so there's still a lot of biologists that say that group level selection is a myth. But my understanding is that you're quite fond of group level selection. I certainly am. It just seems mathematical. But so could you tell us a bit about what that means? I know that, so in David Sloan Wilson's work, I really loved his book, Darwin's Cathedral, which is one of these kind of early applications of evolutionary game theory to explain religious behavior. And in that, he makes a very extended case for group level selection being fundamental to explaining a lot of sociological phenomena. So anyway, I hand it over to you. What's group level selection? Why is it important?
Well, group level selection is where behaviours, strategies of individuals are selected because of the beneficial effects they have on group competitiveness in between group conflicts. It's certainly found in nature in abundance, although I guess maybe it's not the most talked about application of it, but actually the whole way that genomes work can be viewed as a form of group selection, in that you have individual genes within the genome, and each of these genes has its own distinct evolutionary interest. It just wants to reproduce itself. But the way that gene gets reproduced is through the success of the genome as a whole. And so if that's the only way to reproduce, then that creates a very strong incentive to perform, or at least a great reward for genes that improve the functionality of the group. Of course, that can be hijacked because individual genes can go rogue, but that's another story. But yeah, group selection is important in my thesis in the later sort of chapters, where I start talking about the role of other regarding preferences. But actually before that, yeah, I talk a lot about what institutions do, and their analogous forms in biological systems. So you have, for example, forms of behavior that are like punishment or reward for performance in legumes in the way they treat the bacteria in the nodes of their roots. If they've got some bacteria that are producing lots of nitrogen for them, giving them a good deal, then you guys can hang around. If they're giving a bad deal, then they squeeze them out, send them packing. You've got markets for cleaner fish services. Cleaner fish will offer to take a parasite off your back, but sometimes they take a bite, and so there's a sort of funny dynamic where if there's a monopoly in a local area in providing the cleaning service, then the fish are less picky.
Yeah, fascinating.
The price is higher. The price is effectively that you get a chunk taken out of you when you visit, but you have to pay that price because it's your only option. So it's a sort of monopoly situation. But yeah, that's actually it's not institutions, but none of this stuff in biology you can say is institutions, but it's where it's similar is that the way institutions work is by they detect whether you've played a certain strategy, like you stole something, or you didn't pay your taxes or whatever else. There's some sort of monitoring system. Did you take a bite out of my skin? Did you take a chunk out of my back? And then there's a punishment or a reward if it was the right behavior, if it was something that that we wanted. If you're a teacher and you did teach students, you get paid, you get to keep your job, and so on. If you are a thief and you steal something or you evade your taxes, whatever it might be, we because that's a defection strategy with a positive private payoff, we want to have an institution that punishes and reduces that payoff so that it's no longer attractive. And so this is the way that there are really two ways of generating cooperation. One of them is through this system of monitoring and enforcement, where you see what behavior, what strategy the actor played, and you punish or reward. And that's entirely how institutions work. And that's entirely one body of theory about human societies work, is that we've got perfectly self-interested actors. And the way that you generate cooperation is by identifying what they've done and rewarding it or punishing it. And the other mode of generating cooperation is via other regarding preferences and the sort of behaviors that we get from things like group selection, where people will weight payoffs of other agents. They're not just behaving in a self-interested way. And, that brings us back to our earlier discussion of the family. So that's an obvious area where other regarding preferences creates cooperation. You don't need an incentive structure in order to want to feed your baby. Or most people don't. And when it comes to group selection, for a lot of people, you don't need a reward or punishment to make some contribution to the success of a group that you identify with. And that becomes very important in politics. But I'll stop talking for a moment and let you butt in and keep me on track.
Right, sure. So I think maybe it's useful to just delineate some of these styles that you pointed out with examples. So it seems to me, but correct me if I'm wrong, that zebras, for example, would be a self-interested form of group selection. There's no other regarding behavior in a sense. So the zebra pack functions more effectively as a pack against predators if the zebras huddle close together and have stripes that mimic each other. If you suddenly had a zebra with a completely different pattern, that would be bad for that zebra. But it would also be bad for the pack in general. It would make it more visible to lions.
Yeah, sometimes things line up such that what's good for the individual is good for the group by happy coincidence, and you get something that looks like cooperation, but is actually each one just sort of by an invisible hand doing what benefits the mass. But as you're implying, as you're, I think we're going to go on to suggest, that doesn't always work. And the invisible hand also has its dark side, where individuals will optimize and do what's worse for the group. But on the zebra point, like it's quite interesting to think about the things that could evolve sometimes cooperatively. You can see, you know, why don't these giant packs of migrating ungulates, who are, you know, they're devastatingly powerful. If they were to team up for a moment, they could wipe out any predator attacking them. But evolution has not been able to find a way to shape their incentives so that they can actually cooperate and do this. So they, and the problem is that it's always better to not, for the individual, it's always better to not participate in providing this. You know, the wildebeest could get together and exterminate all the lions, but who's gonna coordinate them? Who's gonna organize the wildebeests into a collective action unit?
Yeah, well, so it's interesting you mention that, because my understanding is that actually the way some pack animals hunt, it looks like a coordinated assault, but it's actually that the alpha takes the highest risk by going in first, and then the other members of the pack just kind of pile in opportunistically behind them. And the part of the reason why the alpha then gets the largest share of the kill afterwards is because they took the highest risk. And so this apparent coordinated assault on the prey is not really coordinated at all, except insofar as people are like noticing that someone else's effort has left a weak spot on the other flank or something, and then they pile into it. Yeah.
I mean, it's still social.
Sure.
But it's not. It doesn't necessarily have to emerge from there being some sort of, you know,
shared intentionality.
Bob saying to Greg, like, you do this, I'll do this. You know, next time I'll do this, you do that. Gee, that worked really well last time. And, you know, sketching something out in the sand.
And that sort of behavior is very quite unique to humans. That sort of shared intentionality. Like, so I know that Tomasello says that the behavior of monkeys, where one monkey pulls down a branch, the other picks the fruit on the branch, and then they share the spoils, is actually, from an evolutionary point of view, an extremely hard behavior to bring about, because they need to understand what they're doing. They need to be able to cooperate in quite a sophisticated way, and then they need to, the one who picks the fruit needs to not defect and run off with it while the other one's on the branch. And that sort of behavior is relatively straightforward to explain in ants or bees because they all share genetics. But it's much harder to explain in species that aren't kin in that immediate way that ants are.
Yeah, it turns up in some parrots too. And you know, there's some socially gregarious parrots that live in groups that are they tend to be quite altruistic, which is interesting. That's even rarer. Where they'll help out even when they don't get any benefit. But then a parrot that's almost, I wish I could remember the names, but that's not my forte. It's almost genetically identical, but has a different social environment and completely self-interested, has, you know, completely ignores the other birds in the exact same experimental setup. So it's quite interesting.
Okay, so I think if we bring this back towards the Red Queen's race, I guess the sort of interesting thing that group level selection helps to explain is that you can imagine that a human tribe that is very cohesive. So the alphas do participate with everyone else in a kind of coordinated strategic hunting behaviors, and that allows them to take down mammoths and then eat all that protein, and the tribe gets stronger. Will be more effective than a tribe where the best hunters know that they can just get by on their own, and so they hunt as lone wolves in a sense, feed themselves, but the tribe in a way mostly decays because a lot of the low quality hunters who would have benefited from all that protein and might have turned into more effective hunters in the long run just
Mhm.
safe shit, as it were. And so what we want to explain in some ways is what brings about a situation where these kind of group level effects start to kick in. So the more altruistic tribes prosper in the long run, and then outcompete and eventually, in human affairs at least, wipe out the less altruistic tribes.
Yeah. And how would you relate that to the Red Queen's race?
Well,
It's a
so
little
my
different to,
understanding, sorry?
it's a little different to my sort of approach to it. I don't know if I disagree. I'm just interested in
I
your
would relate it in the
angle.
sense that, if I understand correctly, the Red Queen's race, so it's a reference to Alice in Wonderland, where the Red Queen says, here you have to keep running to stay in place.
Yeah.
But your
Yes, it's
application, yeah.
Oh, it's a great little bit. It's Alice says, where I'm from, if we run this fast, usually we get somewhere.
Yeah.
And the Queen says, slow sort of race.
Yeah, right.
If you actually want to move, you have to run twice as fast.
Yeah.
Yeah.
So that, I guess, comes into evolution then, that you're always in an evolutionary contest. And so, like, if you as a predator don't keep evolving, then eventually your prey will evolve techniques to avoid
Right.
it. But I think where it comes into the Red Queen's race is that you applied this notion to models of parasitism. And it seems to me like a parasite is in a way of employing a defection strategy in some kind of strategic game. This is in human society, this is like corruption or rent seeking, or just kind of benefiting yourself at the expense of the group. And so it seems to me like group level selection is an important aspect of applying the Red Queen's race and associated models of parasitism to human society, because human societies that are unable to resolve this Red Queen's race and clamp down on parasitic behavior collapse in the long run, or get outcompeted by those that can reduce parasitic behavior.
Yeah, well, so the Red Queen's race, I feel like maybe I've got to give it a little bit more of an introduction.
Yeah, for sure.
So Van Valen, a biologist, I think it was back in the 70s, came up with this idea, and naming it after Lewis Carroll's In the Looking Glass. And it's basically the idea that when you have some sort of competition, some sort of conflict between any two species, they're going to be engaged in a co-evolutionary race where, over time, a mutation that advantages one, so that it starts doing better in the race, is going to increase the payoff for a counter innovation from the other party. And so you get this sort of innovation, counter innovation, innovation, counter innovation dynamic going on. And so in his model, the average expected fitness of the two races, say it's like a fox and a rabbit, the average expected fitness is, it's going to stay flat, because we don't really have much of an idea about which one's going to do better. So we roughly expect them to stay even, but in practice they don't. It's variable. So the fitness of one relative to the other is variable. In one lucky period for the rabbit, they develop some, new way of doing their burrows that, or hiding their scent, or whatever it might be, that fools the foxes, and so they do better. And then in the next period, it's again, in Van Valen's model, it's stochastic. So the fitness sort of change in any given period is normally distributed for Van Valen. And then that means that the fitness gap between the two, so if both of them have a normally distributed fitness in a given period, then the fitness gap between them is also normally distributed, but has twice the variance. It's larger. And so basically, when a certain threshold of the fitness gap, when a certain threshold gap is reached, one falls behind the other racer too far, then they go extinct.
Right.
So, you know, your
Dodos.
your dodos, or say pretty much any of the 99.9% of species that have gone extinct, they lost the race at some point. Is the idea. Though the red queen's race is strictly to do with evolutionary pressures that relate to between species or within species, basically between biological agent interactions. And there's something called the jesters. I can't remember the jesters race. I don't think it's the jesters race, but it's the jester effect is to do with environmental change causing extinction. Right. So both of them are important, but we, biologists have witnessed extinction due to the red queen's race taking place, in real time, many times in actual systems. And one of the key applications is to study parasitism, where parasites present an interesting case because they're smaller than their hosts. They tend to reproduce a lot faster. So if you look at bacteria or COVID-19 or whatever it is, it reproduces about once every 15 minutes. Yeah. Whereas it takes us at least 15 years. So if you're evolving new strategies by mutation, you've got billions of bacterial parasites that are reproducing rapidly. So they're trying out many strategies. They're exploring the evolutionary space a lot faster than we, the host, would be. And so this is actually a driver of sexual reproduction in the first place. It's thought to be the main driver of sexual reproduction. And basically the lesson of it is that in the red queen's race, you're facing a future of uncertain innovation. The main way you stay alive is you invest in innovation capacity to keep ahead of your parasites. And sexual reproduction is actually very, very costly in terms of resources compared to asexual reproduction. But the asexual, in various studies of asexual communities that are, you've got an asexual snail community that's otherwise identical to a sexually reproducing snail. The asexual ones die to their parasites because they don't keep up. So it's these investments in innovation capacity. And I draw a parallel with the red queen's races that go on in market societies, where we have, we set up a bunch of institutions to protect property rights, institutions to prevent certain sorts of, contract violations or misleading practices, or, establishing monopolies or whatever it might be. And there are very large incentives to parasitic strategies that find ways around these, that find ways to, stash money away in the Bahamas or whatever it might be. And this creates a red queen's race between the regulator and the regulated parties. In a sense, this is what the literature on sort of principal agent problems in regulation are also talking about. And then you have a principal that's got to regulate a supervisory intermediary, and that supervisor regulates the market actor. And the market actor is trying to fool the supervisor or collaborate with the supervisor, and the supervisor may be trying to fool or maybe trying to work with, depending on how their incentives are structured, the regulator. And the task is to keep ahead. So the regulator needs, in order for to get an efficient outcome, you need both the regulator to control the supervisor well, and the supervisor to have the capacity to control the market actor. And those require investments in the capacity to keep up. And I mean, I sort of want to go on and get to my get to where this sort of logically leads to in my PhD, but you've probably got a structure in mind that I'm ripping to
No. I
shreds.
mean, go ahead. I guess maybe just before you turn to, I suppose, the Red Queen's relay is what you want to talk about next, is just what are some quick examples maybe of an area where the regulator has kept up, like it's done pretty well, and what's an area where you think the market actor is starting to parasite very effectively, just to help people map these concepts onto the real world?
An area where the regulator has kept up.
Yeah.
Let me take a glass of water.
Sure.
I
think like pirate behavior in large parts of the world is kind of eradicated, for example.
What's that, sorry?
Pirating,
Yeah.
Not just digital piracy, but I mean like good old fashioned raided with a boat piracy.
That's
largely
a good point.
eradicated.
It's mostly eradicated. Yeah, there's still I don't know what's happening on off the coast of Somalia now, but
but that's because there's an institutional vacuum there. So in the places where the institutions are functional, it's very hard. The pirates lack the resources to innovate new piracy strategies. Whereas in the digital domain, it's much easier to innovate new strategies of piracy. And so I think we still see a lot of interesting stuff, in part because Russia provides an area with institutional vacuum for pirates to locate.
Yeah,
if that makes sense.
Whereas
I guess
absolutely.
An example of where the regulator is really struggling to keep up would be complex financial services.
Yeah, well, there are abundant, I guess I was sort of jokingly saying before, an area where they're keeping up, because mostly my thesis has been, I guess my attention has really been focused on the failures.
Yeah, effective
because they're obviously what we go to. I think that's actually generally a problem in how we think about government, is that our minds go straight to the failures. When there's an extraordinary number of successes. Societies generally, advanced economies generally work pretty well. They're pretty safe. And life is much better than it was historically. But yeah, we have these unfathomably large and costly mistakes, like in financial services. I mean, the complex derivatives that were sold in the lead up to the financial crisis, there was just so much parasitism going on there on multiple levels. So it's probably worth introducing the Red Queen's race through this sort of example, especially because that's something I actually need to write tomorrow.
Okay.
But the global financial crisis, you had parasitism going on at the level of market actors, as in between individuals and firms. So you had firms devising ways that they could basically find more vulnerable, people with minimal financial literacy, and dupe them into buying these products that were no good for them and that they couldn't actually afford. Because when these people failed to cover the home loans that they were given, the banks could just go and repossess the homes, which they assumed, which is the whole problem of the financial crisis. They assumed that the homes would continue appreciating in the meantime, so that they would they'd make money, on every turn of the deal. Then you've got a second level to this, which is that so the first level is the between market actor level, which is really about the differences in rationality between the agents involved, because markets run on rational, voluntary exchange. If we've got a perfect market and agents are rational, so they can rationally identify their own interests, and in an efficient market, we have arranged things such that when you identify your own interests, you also at the same time maximize the group benefit. It's the whole invisible hand concept. And when agents are irrational, they can be exploited, and that function isn't performed. So, you can take the extreme example of a system that's perfectly regulated, except that you've got completely irrational market actors who can't identify the value of things. Then the market society doesn't work at all. There is no group benefit without agents that are rational enough for the task that they have to complete in the market, for the voluntary exchanges they have to make. And so, well, that sort of brings us up to the next level, which is the way that we regulate the market, because it's a failure of regulation if market actors have to, if we're expecting individuals to solve problems in the market that are too complex for them. That's a failure of regulation. There are many kinds of failure of regulation, and that's just one of them. So in this second level, which is the race largely between firms and the regulator, you've got a regulator that is trying to, we assume the regulator's ideal, and the regulator's trying to develop ideal institutions that will make market actors compete in an honest fashion, well, a fashion that is basically satisfies the logic of the basic logic of markets. Preserves free entry, doesn't involve anti-competitive practices, doesn't mislead consumers or exploit them. Doesn't evade taxes.
Essentially, you get ahead because your product is better and people buy it.
Yeah, you follow the rules of the game, and within the rules of the game, if everyone's playing fairly by the rules of the game, then you've got more demand at a price that justifies production, and so you win. And that's how the market's supposed to work. So, but of course, you have another Red Queen's race. So before we spoke about the Red Queen's race between, at the market actor level over whether consumers are rational enough to identify the payoffs of the products being offered by producers. So it's a race between producers and consumers. This is a race between firms and the regulator. And so in this case, we don't have the banks duping consumers, but we've got banks that are devising these exotic derivatives that are far too complex for the regulator to understand, and that evade existing regulations that aren't properly covered. And so it's this process of innovation in the Red Queen's race that delivers these novelties that are sometimes good, sometimes they're mutualistic, but sometimes they're parasitic. And then the third level above the regulator firm race is the race for control of the regulator.
Yeah.
So we stop assuming at that level that the regulator is benign, and we start to introduce the possibility that the regulator has its own interests, and the regulator's interests can be manipulated. No, well, what I mean is the regulator can be bought off, basically, and the way that the regulator is controlled is via, the voter, ideally. So you have, the way the whole system works is you have the voter at the top. They elect a political figure on the basis that they're going to provide some sort of social economic outcome. The political figure then has incentives to deliver on that, which means providing incentives down the chain to their, the various subordinate actors to do their jobs in certain ways, to craft such and such regulations. These regulations are then applied to these firms and individuals in the market, and we leave some last bit to individual rationality to solve the problem of whether something's actually worth buying or not. And so at this top level, where the voter is supposed to control the regulator, well, you also have regulator innovations in concealing what they're actually doing when they're making deals with, in the case of the financial crisis, they're making deals with the banks, getting very, very chummy. I mean, the period in the 1990s where I give quite a bit of detail on this in my thesis, where the process by which the old legislation, I forget the name.
Glass-Steagall Act.
Yeah, the Glass-Steagall Act. Graham Bellici or something. What's the one that replaced it? But anyway, but yeah, the Glass-Steagall one is the important one from the Depression era that was replaced, and that separated commercial and investment banking. And so then that division was broken up, which was very lucrative for banks that could now use retail customer capital for these higher risk investments. And so it created this whole possibility of systemic risk. And a lot of that was because of extremely close relationships between bankers and politics, and some massive revolving door things. I wish I was in a bit of a better mood for remembering names. I remember the name of the guy who entered the Clinton administration, changed the law, and then left right back to JP Morgan Chase or one of those ones for a massive pay packet, which is about as explicit as it gets. And so what you've got is this process of we want to create a system, a society where individuals are innovating and choosing strategies that are beneficial for the whole group, for society as a whole. That's how we get economic growth. But at every step along this process, from voter through regulator, through firm, and down to market actors, we have these innovation races taking place, where there's opportunities to parasitize the system and claim resources without actually contributing.
Okay, great. And so you've demarcated these multiple levels of the Red Queen's race. So you have between market actors, between regulators and market actors, and then between government and the regulator, or between various actors and the regulator. Do you have some kind of snappy name for this multiple level of Red Queen's race?
I think you've already said it a few times. Red Queen's relay.
Yeah. The Red Queen's relay.
The Red Queen's relay, yeah. So there's 3 legs in the relay, and you've got to run a good pace in each of them if you're going to get an efficient overall outcome. And what I try to show is that, and this is where you start to get to some of the conclusions of the thesis, or at least one part of it. What I try to show is that the way that people have thought about markets as being this sort of self-regulating structure, and of institutions as being self-regulating too. You had like the idea of Hayek, for example, was that you set up this ideal constitution that constrains regulators substantially, and so you have a sort of minimally regulated market with basic property rights, free entry, that sort of thing. And then it's like a clockwork constitution. It runs itself out till the end of time, and produces optimal results all along the way. And what happens though is, well, you've got you're dealing with a highly uncertain, innovative system, where a lot of what, it's interesting, the sort of blindness, the sort of one-sidedness of his vision, which was, was an impressive vision, but he observed that with when it came to markets versus central planning, the advantage of markets was that they harness distributed knowledge, that they take all this knowledge that individuals that individuals have about particular opportunities, local opportunities to produce this or that, or about their own desires for various products. And all this stuff, all this knowledge can't be centralized into a central planner. But when you have a price system and you have supply and demand, it forms a price, and that price is what coordinates everybody to use their knowledge appropriately. But the problem is that the knowledge that you require to know that markets are going to be self-regulating into the future, you require a great deal of knowledge about future innovations, future social innovations, future political innovations are going to be caused by whatever the consequences of markets are, and technical innovations, strategic business innovations, all this sort of stuff where the effect of markets can change substantially. And so what's happened is I sort of talk about the tortoise and the hare. So in a Red Queen's race, if you stop running in the race, you lose. If you pull the hare's strategy, doesn't matter how far ahead you are, you lose the race. And in this sense, you can understand the self-regulating market argument as saying that we can basically fall asleep. We've set it up, we have an unbeatable strategy, and now we just leave it, set and forget. And the problem is that it's been captured very quickly. And so this was most politically influential into the 1980s. These ideas under Hayek and Friedman, Thatcher, Reagan. And since that time, since exactly 1980, we have had a massive increase in rent as a share of GDP, fourfold increase in rent as a share of GDP, massive increase in inequality, so that especially in the US, where the median worker has basically seen no wage growth, even though GDP has increased. I don't know what it's increased over those 40 years, but at least doubled.
What? Yeah.
Yeah. And so, everybody should be, all the average people in the US should be a lot richer. They should have a lot more money. And I think it would be a very different society if the average person was that much more comfortable, and, if life was that much easier. But anyhow, so you've got this. The self-regulating theory is basically says we should fall asleep in the race. And if we accept the logic of the Red Queen's race, the main arguments of it being that innovation is open-ended and uncertain. We don't know what's coming. What's coming can significantly change the nature of the games that are being played. And so any system of rules that you devise must actually be adaptive. And furthermore, maybe we'll get to it later on, although I think maybe we might run out of time. But
yeah, we've got about 5 minutes left.
The main thing I want to argue in my thesis is that it's actually impossible to have an institutional structure, a purely institutional structure that is adaptive.
Yeah.
I don't know if we'll get around to that.
Well, I was going to say maybe one thing to conclude on, an idea in your thesis that I like quite a lot is, the point you just made is if I try to distill it down to something very short, is that, so Hayekian theory is that the market innovates, the market makes use of distributed knowledge, all sorts of dynamic, cool stuff happens there, price signals send all the information around, and everything just gets better and better, and that the institutions can be set in stone, but that doesn't really work because of all the changes that innovation brings, in particular innovations in parasitic behavior on the institutions. But then the kind of other side of that coin is that statist approaches, say the Soviet Union, but we could think of a more kind of idealized Soviet Union, so even the better sides of the Chinese political economy at the moment, that are much more technocratically sophisticated, I think. So I'm not very fond of the CCP, but I think it's worth underlining that they have been quite technocratically sophisticated in a lot of areas for the last, say, 20 and 30 years. Even that sort of approach, which tries to be very rational and tries to really bring reason to bear to improve regulation and that sort of thing, can't match the level of efficiency of an evolving system. And so one of your conclusions, if I understand it correctly, is that we need to find a way to combine both evolutionary forces in the way we think about regulation and institutional design and this sort of thing, and rational forces. So on the one hand, we can conceive of better regulation, but then we also need to try to find ways to allow innovation to happen in that space. And so we need to kind of balance these two things, and that way, in a sense, we bring about a Red Queen's race in the relay, because you have people trying to innovate on your parasitism, but then you also have innovations coming both from evolutionary pressure and from rational action to try to combat those parasites. Is that broadly correct, if I represented your work well?
Yeah, I mean, I think you've represented quite well that I'm trying to find that that middle road that uses both of these different optimization approaches in their right place. So rational, as you say, central planning just can't approach the creativity of the market. And it just can't access all the required knowledge. I think Hayek was quite right on that count. It'll be interesting to see how that changes. I don't want to say that that's a permanent state of affair, because we're dealing with a Red Queen's race, and we're dealing with an uncertain process where, for example, the emerging ICT technologies, all the monitoring and data gathering that might change how much central planning is optimal, in the sense of what makes for a competitive state, and maybe we'll be forced to do more of it, even where we would rather not, but I'm not sure. But yeah, we need to use, I think we need to be more rational than Hayek, as in use more rationality than he wanted to use, because he thought the system had to purely evolve. Yeah. But as I argue, that results in the wholesale evolution of parasitism as well. And so we have to find a way to rationally control the evolutionary process. We're basically providing guide rails for it. And one of the key insights is that we need to be careful about how complex we let the system become. Because if it becomes too complex, we can't control it. Yep. And so if we allow hyper exotic derivatives that no regulator understands, there will be parasitism, no doubt. It's just the system will be captured. Wherever we let that happen, wherever that we let the complexity exceed our ability to do monitoring, we don't need to rationally do all the creating and all the the planning of things, but we need to be able to understand them and monitor them, and that's the purpose of rationality.
Yeah, great. So yeah, simple tax systems and that sort of thing. Yeah. All right, wonderful. I think we should. Yeah, go ahead.
I was going to say simple. One of the beautiful things about Glass-Steagall was that it just dealt at the level of interests. It said you can't mix up the function of banks as these sort of reliable stores of wealth for individuals, and the function of banks as providing high risk capital to high risk projects. If you mix those up, you're going to cause trouble. So let's keep them separate. And then the other approach was, no, let's mix them together, because we're going to get these tiny gains out of it, and we can keep track of it. Don't worry.
Yeah, that's a great example that we can keep track of it, and that's the kind of rational hubris where rationality is kind of misdirected. Wonderful. Well, I look forward to the final product, and hopefully we'll have a book available for public consumption at some point. And I'm sure I'll keep the listeners posted on that. But I think it's been a great conversation. Thanks for having me on, Reuben.
Great pleasure. Thanks for having me.
Apodstomology. If you enjoyed today's discussion, do check out Apodstomology's page at your favourite podcast directory for more episodes on topics as diverse as tax policy and the meaning of life.